Welcome to this lecture. Important multiple choice questions from physical pharmaceutics for GPAT and other competitive examinations like railway pharmacist as well as pharmacy officers. Various competitive examinations will conduct central government as well as state government. So those aspiring minds, this video is helpful for that aspirant student. This is the syllabus of physical pharmaceutics second. Already we teached about physical pharmaceutics 1. In that, solubility, state of matter, surface tension and interfacial phenomena, complexation and protein binding, and as well as pH buffer and isotonic solution. This is already discussed in previous lectures. So today we'll discuss about unit 2 multiple choice questions that is will definitely asked for competitive examination. So this is a physical pharmaceutics second syllabus. So in that multiple choice questions will ask in physical pharmaceutics 2. In that first, that is question, which of the following is not a type of colloidal dispersion? So first upon, colloidal dispersion is a polyphase system, means it is a two-phase system like suspension and emulsion. Suspension also two-phase system, emulsion also two-phase system. Suspension in that solid and liquid, and emulsion in that oil and water. So question, which of the following is not a type of colloidal dispersion? So here, not a type of colloidal dispersion. Dispersion have three types: colloidal dispersion, coarse dispersion, and fine dispersion. So option 1, that is sol, option 2 gel, option 3 aerosol, and option 4 suspension. So suspension is the correct answer, because suspension is a coarse dispersion, not a colloidal dispersion. And remaining sol, gel, aerosol, that is a colloidal dispersion example. Next, second question, which is the typical size range of colloidal particles? What is the typical size range of colloidal particles? 1, that is 1 to 100 nanometers. Second, 1 to 100 micrometers. 3, that is 1 to 10 millimeters, and 4, less than 1 nanometer. So colloidal particles size range between 1 nanometer to 100 nanometers, that is a colloidal particle size range. Next question, which property allow colloidal particles to scatter light, transmit the light? First, Tyndall effect options. Second option, electrophoresis. Third, Brownian motions, and 4, coagulation. So first option is correct, Tyndall effect. Next, Brownian motion in colloidal particles. Next, fourth question, Brownian motion in colloids refers to: first, light scattering by colloid particles. Second, random movement of colloid particles due to the molecular collision. Third, separation of colloid particles by gravity. And fourth, formation of precipitate. So Brownian motion, moving, random movement, option second is the correct, random movement of colloidal particles due to the molecular collisions. That is the correct answer. Next, turn to the next question, question number 5. What is peptidization in colloidal dispersion? What is peptidization in colloidal dispersion? 1, conversion of colloids into gel. Second, is the process by which coagulated or settled or flocculated colloidal dispersion is redispersed into original colloidal form by the addition of an appropriate dispersing agent, also called as peptidizing agent. Means that colloidal dispersion is those which is coagulated or settled. Flocculated colloidal dispersion is redispersed into the original colloidal form by the addition of appropriate dispersing agent. Another, this process helps to break up the aggregated particles and stabilize the colloidal system, restoring the uniform dispersion of the particles in the medium. Conversion of colloidal into gel is not correct answer. Option 4 is the correct. Both 2 and 3 is the correct. Colloidal dispersion, peptidization is a process by which coagulated settled or flocculated colloidal dispersion is redispersed into the original colloidal form by the addition of appropriate dispersing agent. And second, this process helps to break up aggregated particles and stabilize the colloidal system, restoring the uniform dispersion of the particle in the medium. So option 4 is the correct. Next question 6. Which type of colloids is formed by solid particles dispersed in a gas? Which type of colloid is formed by solid particles dispersed in a gas? First sol, second gel, third foam, and fourth that is aerosol. So option 4 is the correct. Aerosol is a pressurized dosage form. It contains solid particles dispersed in a gas. Next question. The charge on colloidal particle is stabilized by first addition of electrolyte, second protective colloids, third electrical double layer, and fourth coagulation. The charge on colloidal particle is stabilized by first addition of electrolyte, second protective colloids, third electrical double layer, and fourth coagulation. So that is third number, electrical double layer. The charge on colloidal particle is stabilized by electrical double layer. Next, coadsorption is a phenomena that involves first aggregation of colloid particles due to the phase separation, second peptidization of colloid particles, third formation of gels, and fourth scattering of light by colloids. Coadsorption, phase separation. Microencapsulation development, that also coadsorption phase separation techniques is used for manufacturing of microencapsulation. So microencapsulation means encapsulation of or covering of particles to the capsule, microencapsule or tablet to protection of the drugs for degradation. So option 1 is the correct. Aggregation of colloid particles due to the phase separation. Coadsorption is a phenomenon that involves phase separation, may separate the phase. Emulsion also occurs, phase separation, separate out the phase. Next, which of the following properties is classified as kinetic property of colloids? Which of the following properties is classified as kinetic property of colloids? 1. Brownian motion, second Tyndall effect, third electrophoresis, and fourth coadsorption. Option 1 is the correct. Brownian motion, movement of particle due to the collision. Next, the addition of electrolyte to colloids can lead to one coagulation, second stabilization, third peptidization, and fourth optical activity, means plane polarized light. So option 1 coagulation, the addition of electrolyte to colloids can lead to coagulation. Next 11, question number 11, protective action of colloid is measured by 1 gold number, second Tyndall effect, third peptidization factors, and fourth zeta potential. So first is correct, gold number. Gold number, it can measure protective action of colloids. Next, which of the following is a classification of colloids based on their general properties? Which of the following classification of colloids based on their general properties? First, solid, liquid, and gases. Second, lyophilic and lyophobic. And third, Tyndall effect and Brownian motion. And fourth, hydrophilic. Option 2 is the correct. Lyophilic and lyophobic is classified colloid based on their general properties. Solid, liquid, and gases based upon state of matter. Next, question number 13. Electrophoresis. Electrophoresis in colloids refers to first, random movement of colloid particles. Second, movement of colloid particles under an electrical field. Third, coagulation particles, and fourth, none of the above. Electrophoresis, electric current field. Movement of colloid particles under an electric field. Second is the correct. Next question, which of the following statement is true about lyophilic colloids? Lyophilic colloids. First, they are highly stable and do not easily aggregate or precipitate. Second, they are also called as solvent loving colloids. Both statements are correct. Question number 14 answers is, that is third. They are lyophilic colloids, they are highly stable and do not easily aggregate or precipitate. They are also called as solvent loving colloids. Next, 15 question 15. Which of the following properties are characteristics of colloidal dispersion? Which of the following properties are characteristics of colloidal dispersion? First, optical properties. Second, electrical properties. And third, kinetic properties. Optical properties, in that colloid particles scatter light resulting in Tyndall effect. Electrical properties, colloid particles acquire charge leading to electrostatic repulsion and stability. Kinetic properties, colloid particles exhibit Brownian motion, which is the random movement of particle due to the collision with molecule in the dispersing medium. So option 4 is the correct. All colloidal dispersion properties, that is the optical properties also, electrical properties and kinetic properties. First, what is Tyndall effect? Tyndall effect means a beam of light passing through the colloidal solution of milk or fog. Tyndall effect, the beam of light passing through the colloidal solution of milk or fog. The particle in the colloid scatter the light, making the beam visible as it moves through the dispersion. Electrical properties, electrostatic charge. Example, in colloidal solution like silver sol, the colloidal particles may acquire negative charge. This charge causes particles to repel each other and preventing aggregation and helping the colloid to remain stable. And third property, that is kinetic properties, Brownian motion. A colloidal solution like dilute ink dispersion in water. The ink particles undergoes continuous random motion due to the collision with water molecule. The motion is an observable characteristics of colloidal particles. That's why all the properties of colloidal particle, that is the explanations, optical properties, electrical properties and kinetic properties. Next, unit 2, in that questions asked, flow behavior of Newtonian fluid is characterized by. Flow behavior of Newtonian fluid is characterized by. Question is that the flow behavior of Newtonian fluid is characterized by, first, constant viscosity independent of shear rate. Second, fluid flow in a predictable manner when force is applied. And third, this means that the Newtonian fluid, the viscosity does not change with variation in the shear rate. Example, Newtonian fluid include water, most simple liquids, and fourth, that is time dependent viscosity. So answer 1 is correct, 2 is correct and 3 is also correct, but 4th is not correct. So there is need all of the above. Make it change. Flow behavior of Newtonian fluid is characterized by constant viscosity. Newton fluid, constant viscosity independent of shear rate. Another, fluid flow in a predictable manner when force is applied. Another, Newton fluid, the viscosity does not change with variation in the shear rate. Example, that is water. Next question, the SI unit of kinematic viscosity is 1 Pascal, PA, second Stokes, third meter square per second, and fourth Poise. So third is the correct, meter square per second. Next question, which of the following is an example of pseudoplastic fluid? The pseudoplastic fluid, this behavior is also known as shear thinning, or fluid whose viscosity decreases as the shear rate or applied stress increases. Pseudoplastic, also called shear thinning fluid whose viscosity decreases as the shear rate applied increases. First water, second blood, third paint, and fourth that is glycerin. So water is a pseudoplastic flow, that is a non-Newtonian flow. First upon, non-Newtonian flow in that plastic flow, pseudoplastic flow, and dilatant flow. That is the three types of flow. So Newtonian flow in that we will seen in previous example, that is water is the example. Another, blood also example of Newtonian flow, glycerin also example of Newtonian flow, but paint is a pseudoplastic flow. Pseudoplastic flow, what they say, this behavior is also known as shear thinning fluid whose viscosity decreases as the shear rate applied stress increases. So option 3 is the correct, paint. Next, dilatant system exhibit first increased viscosity with an increasing shear rate. Dilatant system, also known as shear thinning system, exhibit an increasing viscosity as the shear rate or applied stress increases. Third, cornstarch in water, example, corn starch in water, example, and 4 all of the above. So option 4 is the correct, all of the above. Dilatant system exhibit increasing viscosity with increasing shear rate. Dilatant system, also known as shear thinning system, exhibit an increased viscosity as the shear rate applied stress increases. So option 4 is the, all of the above is the correct. Next, thixotropy. Thixotropy is best described as first, decreasing viscosity over time under constant shear. Second, increasing viscosity over time under constant shear. Third, thixotropy refers to shear thinning behavior. Substance like paint that are thick and solid when not in motion but become a runner when shaken or stirred. Thixotropy, Sol gel phenomena, decreasing viscosity over time under constant shear. Thixotropy refers to the shear thinning behavior of substance like paint. So option 4 is the correct. 1 and 3 option, decreasing viscosity over time under constant shear, and also refers shear thinning substance like paint. Next, which instrument is commonly used for determination of viscosity in Newtonian fluid? Which instrument is commonly used for determination of viscosity in Newtonian fluid? First, rotational viscometer. Second, capillary viscometer. Third, falling sphere viscometer, and 4 all of the above. All of the above is the correct answer. These are the commonly used instruments: rotational viscometer, capillary viscometer, and falling sphere viscometer for Newtonian fluids. Next, viscoelastic materials exhibit properties: solid only, liquid only, both solid and liquid only, and 4 gases only. So both solid and liquid exhibit viscoelastic material. Next, the Huckel equation is used to describe first, plastic deformation of solid, second, viscosity changes in fluid, Third, elastic deformation in solid. And fourth, relationship between stress and strain. Plastic deformation of solid is the Kale equation used to describe plastic deformation of solid. Next, stress is defined as deformation per unit area, force applied per unit area. Third, change in length per unit original length. And fourth, resistance flow. Force applied per unit area. Stress is defined as force applied per unit area. Have to remember this. Next, elastic module. Elastic module is the ratio of stress to strain, strain to stress second, third viscosity to shear rate, fourth shear rate to viscosity. Second is the correct answer. Elastic module is the ratio of trace to train. You have to correct the answer. That is the first is the correct. Trace to train, not train to trace. Make it the correct or correction. That is the trace to strain is the elastic module ratio. Next, plastic deformation refers to. Question number 11. Plastic deformation refers to first, permanent deformation under stress, temporary deformation under stress, deformation that depends on time, and fourth, elastic recovery after stress removal. So first is the correct, permanent deformation under stress. Plastic deformation refers to deformation means changes. Permanent deformation under stress. Plastic deformation refers to permanent deformation under stress. Next, which of the following best describe plastic flow in rheology? Which of the following best describe plastic flow in rheology? A flow where the viscosity decreases. A flow where the viscosity decreases with increasing shear rate. A flow where material does not flow until a certain yield stress is applied. A flow that is characterized by constant viscosity regardless of applied stress. And fourth, a flow that occurs without any change in material viscosity. Option second is correct. A flow behavior where a material does not flow until certain yield stress is applied. Because the plastic flow refers to the behavior of material that behave like solid up to the certain yield stress and only begin to flow once that stress is exceeded. This behavior is common in material like clay or certain paste which resist flow until a minimum threshold of stress. The yield stress is applied. Once the yield stress is surpassed, the material flow with viscosity that typically decreases with increasing shear rate. Option 1 is given, that is refers to shear thinning or pseudoplastic flow. Option 3 describe a Newtonian fluid where the viscosity remains constant, and option 4 that is might refer to solid or non-flowing material. So option 2 is the correct, flow behavior where a material does not flow until a certain yield stress is applied, that is a plastic. Next, turn to the third unit questions. Coarse dispersion have particle size. Coarse dispersion have particle size. First, discuss the question that is colloidal dispersion. Dispersion have three types: colloidal, coarse, and fine dispersion. Second, that is question, colloidal dispersion have particle size range typically 1 to 10 nanometer. So that is a colloidal. Next, 0 to 1 micrometer. Third, 10 to 50 micrometers. And 4, above 1 micrometer. So fourth is the correct answer. Above 1 micrometer, that is the size range of coarse dispersion. Example, that is suspension and emulsion, that can be seen by naked eyes. Suspension, in that we seen the particle size in naked eye. Next, the phenomena where a particle in suspension settle down under the gravity is called. Question, that is, when phenomena where particle in suspension settle under gravity is called flocculation. Second, sedimentation. Third, coaguation. And fourth, peptidization. Second is the correct. Sedimentation. Sediment formation, phenomena where the particle suspension settle down under the gravity. Means those particles have largest weight that settle in ground. That's why suspension need a shake well before use, too easy to disperse. Next, which type of suspension shows better physical stability? First, flocculated suspension. Second, deflocculated suspension. Third, both are equally stable. And fourth, none of the above. Flocculated suspension is the correct answer. Which type of suspension shows better physical stability? That is the flocculated suspension. Next, the interfacial properties most critical to the suspension stability is: first, surface tension. Second, zeta potential. Third, contact angle. And fourth, wetting agent. Second is the correct. Zeta potential. The interfacial property most critical suspension stability is zeta potential. Next, the theory of emulsification. The theory of emulsification that exhibit the formation of protective film around the droplet. The theory of emulsification that explain the formation of protective film around the droplet. First, surface tension theory. Second, interfacial film theory. Third, phase inversion theory. And fourth, adsorption theory. So interfacial film theory is the correct answer. Next, which type of emulsion is used for controlled drug delivery system? Controlled drug delivery system means those drug delivery system have controlled release of drug in controlled manner. Means novel drug delivery system. Controlled drug delivery system follows zero order kinetics, does not depend upon concentration. Which type of emulsion is used for controlled drug delivery system? First, simple emulsion. Second, micro emulsion. Third, creaming emulsion. Fourth, sedimented emulsion. So simple emulsion is not used for controlled drug delivery system. Third, because particles droplets have largest droplet size, that's why simple emulsion is not utilized for controlled drug delivery system. So first option is cancelled. Third, creaming is also not utilized. Sedimentation, those particles settled ground state, that also not utilized. So micro emulsion is the correct answer. Micro emulsion means those droplet size smaller the droplet size, they have penetrate more. So targeted drug delivery system, controlled drug delivery system, that is targeted drug delivery system. That drug delivery system, in that drug is delivered to the target site. Controlled drug delivery system, drug is delivered in a controlled manner, predetermined time. Next, the hydrophilic lipophilic balance HLB method is used for: first, determine the viscosity of emulsion. Second, selecting emulsifying agent. Third, stabilizing suspension. And fourth, measuring sedimentation rate. So hydrophilic lipophilic balance. Second is correct. Selection of emulsifying agent or suspending agent. So there is a role of HLB scale. So selecting emulsifying agent. Next, which property is directly related to emulsion stability? Means breakdown of emulsion. First, that is creaming. Creaming what? The dispersed phase oil droplet, for example, rises to stop due to the difference in density. Oil droplet reaches in top upper side, that is the creaming. Second, coalescence, droplet merge together leading to phase separation. And phase inversion, change in phase, emulsion one type to oil in water to water in oil to another. So all of the above is the reason for breakdown of emulsion or phase instability. Next, the type of emulsion with oil dispersed in water is: first, water in oil emulsion. Second, oil in water emulsion. third multiple emulsion, and four micro emulsion. In the type of emulsion with oil dispersed in a water. So oil in water, oil dispersed in water. Second option is the correct. If water dispersed in oil, then water in oil emulsion. Oil dispersed in water, that is internal phase, and water is the continuous phase. Oil in water emulsion. Next, the rheological property describing how fluid viscosity is changes with applied shear. The rheological property describe how fluid viscosity is changes with applied shear. First, thixotropy. Second, elastic module. Third, sedimentation. And fourth, plastic deformation. Thixotropy is the correct answer. Rheological property describe how fluid viscosity is changes with applied shear, that is a thixotropy. Next, which of the following method is preserve emulsion? First, adding stabilizer. Second, use antimicrobial agent, and third, decreasing temperature. So preserve means to improve the shelf life of emulsion, duration of. Preservations means improve the stability of that emulsion. So first, addition of stabilizers. Second, using antimicrobial agent, decreasing the temperature. So all of the above is the correct answer. Stabilizer, it can maintain the stable emulsion. Antimicrobial agent, protection from microbial growth, and decreasing temperature, that also result for preserve the emulsion in longer duration of time. So as you know, emulsion evaluation test, dye test, dilution test, conductivity test, fluorescence test, and cobalt filter paper test. So these are also questions asked in GPAT as well as competitive examinations. Evaluation test of emulsion or applications. Emulsion asked in questions, also applications. So after emulsion, you have to remember the evaluation test as well as applications as well as methods, method of preparation of emulsion. Next, unit 4. The term micromeritics refers to first, study of large particle, second, study of small particles, third, study of molecular properties, and fourth, study of powder mixing. Micro means smaller, determination of small particles. Second is correct, study of small particles. Next, which method is used for determining particle size by counting? Particle size counting. Sieving separate particles based on size using mesh screen. Second, microscopy, visually observing and measuring particles under microscope. And sedimentation, measuring the settle rate of particles in fluid to estimate their size. And fourth, counter method. This is the method which determines the particles by counting. You have to remember. Determination of particle size by sieving. Sieving you have to determine by using sieves. Microscope utilizing to determine the particles by observing. Sedimentation, measuring the settle rate of particles in fluid. Counter method which can determine the particles by counting. You have to remember. Fourth answer is the correct. Next, particle size distribution is essential because, means important because what? Dissolution rate, flow properties, packaging density. Dissolution rate, flow properties, and packaging density. So all of the above is the correct answer. Particle size distributions means equilibrium distribution of particle size. Distribute the particles. Next, which of the following measure specific surface area of particles? First, adsorption method. Second, permeability method. Third, sedimentation method. Question that is, which of the following measures specific surface area of particles? So option 4 is correct. Both 1 and 2, adsorption method and permeability method, measures surface area of particles. Next, what does porosity of powder refers to? First, density of powder. second white space between particles, third surface roughness of particles, and four flowability of powders. White space between the particles. Porosity of powder refers to white spaces between particles. You have to remember, second option is correct. Next, bulk density of powder is determined by first mass of particle only, volume of particle only, third mass of particles per unit bulk volume, and fourth porosity of particles. So third mass of particles per unit volume, third is the correct answer. Next, which of the following method is used to measure the flow properties of powder? Which of the following method is used for measurement of flow properties of powder? First, angle of repose, second, bulk density, third, tap density. So all of the methods which determine flow properties of powder. Next, 8 question. Specific surface area is defined as total surface area per unit mass, total surface area per unit volume, third total volume per unit mass, and fourth total density of particles. Total surface area per unit mass is the correct answer. Next, which parameter represent the ability of powder to pack tightly? First, bulkiness, second, packaging density, third, porosity, and fourth, angle of repose. Which parameter represent the ability of powder pack tightly? First, bulkiness, second, packaging density, third, porosity, and fourth, angle of repose. Packaging density, it can represent ability of powder pack tightly. Next, a powder with high angle of repose. Option 1, easy to flow, second, difficult to flow, third, highly porous, and fourth, highly dense. A powder with high angle of repose, that is difficult to flow, is the correct answer. Next, which of the following techniques is not commonly used for particle size analysis? First, sieving, second, sedimentation, third, filtrations, and fourth, laser diffraction. Which of the following techniques is not commonly used for particle size analysis? Sieving, sedimentation, filtrations, and laser diffractions. So yes, sieving is the method which determines the particle size. Sedimentation is also determination of method. Laser diffraction is also a determination of particle size. But filtration is the process is not measure the particle size. It can be separate of liquid. Water purification filtration process utilized, as well as waste treatment, as well as clarification of parental formulations. Also filtration techniques utilized. Filtration means is a unit operation. Porous medium in which liquid is passes to the porous medium. That porous medium retain the solid and allow to permit only liquid. So ancient time water purification we utilize cloth. So that cloth is act as a porous medium. When we passing of that water to the cloth pores which reaches the solids and which only allow to permit liquid, that is called as filtration. So filtration is not measure the particle size. Filtration is a method for separation. Next, which of the following properties are typically studied in under micromeritics? First, density, particle size, shape and surface area. Second, density, porosity and surface energy. Third, flow properties and packaging characteristics. Fourth, all of the above. So answer, that is 4 is the all of the above. Which following properties are typically studied under micromeritics? Particle size studied, density of porosity, flow properties, particle size needed for how particle interact in medium, density, porosity and surface area help to characterize internal structure, surface characteristics of particles, and flow properties and packaging characteristics essential for evaluating handling, processing and packaging behavior of powders. Next, which of the following is not typically property studied when the evaluating of density, bulkiness, and flow properties of powder. Taper density, bulk density, flowability, angle of repose, and fourth, melting point. So answer, that is melting point is not typically property studied when the evaluating of density. Which are the following not a typically property studied when the evaluating of density, bulkiness, and flow properties of powders. Melting point, taper density, bulk density are key properties related to how powders settle and pack under specific condition. Flowability, acid by properties such as angle of repose, indicate how easily powder can flow, which is important in handling and processing. Melting point is not a property related to bulkiness or flow characteristics of powder, but rather thermal property related to substance phase change from solid to liquid. So this melting point is not directly studied when evaluating of powder density, bulkiness, and flow properties. Next, which following method is used to determine the surface area and permeability of powders or porous material? First, BATE method. Second, mercury intrusion porosimetry. Third, air permeability method. And four, all of the above. BATE method, mercury intrusion porosimetry method, air permeability method, and four, all of the above. All of the above is the correct answer. BATE method is widely used techniques for determining the surface area of powders or porous materials by measuring the adsorption of gases onto the material's surface. Mercury intrusion porosimetry, a method is used to determine porosity and pore size distribution in materials by forcing mercury into the pores under increasing pressure. It provides insight into the both permeability and their internal surface area. Air permeability method, the measure permeability of powders by passing air through the compacted powder bed and observing how easily air flow through it. It provides information about the porosity and flow characteristics of material. So all of the methods provide valuable data on the surface area permeability. So option 4 is the correct answer. These are the table summarizing different particle size determination methods. Laser diffraction measures the angular variation in light scattering from particles. Size range 0.1 micrometer to 1000 micrometer. Pharmaceuticals, food, cosmetics, in that applications of laser diffractions means pharmaceutical, powders, food, cement, cosmetics, in that laser diffraction it can determine the particle size. Next, dynamic light scattering, DLC method. Dynamic light scattering measure Brownian motion of particles in suspension by light scattering 1 nanometer to 10 micrometer. Nanomaterial, colloidal system, suspension. Next, sieve analysis. Particles are passed through the series of sieves and return the mass is measured 50 micrometer to 100 millimeter. Granular material is like sand, soil, and powders. It can measure sieve analysis. Different sieve 10, 22, 44, 85, 120. Next, scanning electron microscopy, SEM, uses electron beam scan as sample surface for high resolution imaging 1 nanometer to several micrometers. Surface morphology analysis, nanoparticles. So this techniques: laser diffraction, dynamic light scattering, sieve analysis, scanning electron microscopy, TEM, transmission electron microscopy, counter method, X-ray powder diffraction. So these are the methods which determine the particle size. You have to remember this. Next, last unit, in a zero order reaction, the rate of reaction is, so already discussed, that is a controlled drug delivery system. In that, zero order follow. It can drug dosage form follow zero order kinetics. It does not depend upon concentration. In the question is asked, that is, in zero order reaction, the rate of reaction is independent of reactant concentration. Second, proportional to reactant concentration. Third, inversely proportional to the reactant concentration. Fourth, proportional to the product concentration. So option first is the correct. independent of reactant concentration, means when we increase the concentration does not affect, so that is a constant. Next, which of the following reaction is classified as pseudo first order reaction? Which of the following reaction is classified as pseudo first order reaction? First, hydrolysis of ester in excess of water. Second, decomposition of hydrogen peroxide. Third, combination of two reactants in equal proportions. And fourth, thermal decompositions of compound. First is the correct, hydrolysis of ester in an excess of water. Third, which factors has the most significant effect on the rate of chemical degradation? First, light exposure. Second, temperature. Third, humidity. And fourth, ionic strength. Which factors has the most significant effect on rate of chemical degradation? So, chemical degradation means losses. Degraded means losses their activity. Second, that is answer correct. Temperature. Temperature is major role, most significant effect on rate of chemical degradation. Next, the Arrhenius equation related the reaction rate constant to first, concentration of reactant. Second, activation energy and temperature. Third, solvent polarity. And fourth, dielectric constant. Activation energy and temperature. Next, photolytic degradation is caused by first, heat. Second, exposure to light. And third, excess moisture. And fourth, acidic pH. Photolytic, light, exposure to light. Next, a drug product shelf life is determined by first, the time taken degraded completely. Second, the time taken 90% of drug remain active, and the time taken 50% of drug to and fourth, the rate of reaction constant. The time taken it take for 90% of drug remain active. The drug product shelf life is determined by the time takes for 90% of drug remain active. Next, question number 7. Accelerated stability testing is conducted to accelerated stability testing. So stability study will carried out for capacity of drug product to identify strength, quality and purity or expiry period. So that's why stability test will carried out. What is the need of stability study? To identify capacity of drug product, strength, quality and purity and expiry period. Accelerated stability testing means improve the temperature. A question that is accelerated stability testing is conducted. First, reduce the production cost. Second, determination the shelf life pharmaceutical product quickly. Third, enhance drug bioavailability. Fourth, evaluate drug solubility. Second is the correct. The determine the shelf life of pharmaceutical product quickly. Next, specific acid base catalysis involve. Specific acid base catalysis involve only hydronium ions or hydroxyl ions, both hydronium ions and general acids. Third, general bases only. And fourth, catalysis by an ion in solution. Only hydronium ions or hydroxyl ions. Next, what is the main method prevent hydrolysis of drug? First, use of antioxidant, use of buffers to control pH. Third, storage in amber glass bottles. And fourth, reducing temperature during storage. Use of buffers to control pH, hydrolysis of drug. Antioxidant prevent the oxidation. Next, question number 10. Oxidation of pharmaceuticals can be minimized by adding preservative. Second, exclusive oxygen and adding antioxidant. Third, lowering the dielectric constant, and fourth, increasing ionic. So here oxidation of pharmaceutical can be minimized by adding antioxidant. Stability study. Accelerated stability study is a testing method used to predict the long-term stability of drug, product or substance by subjecting to higher than normal stress conditions such as elevated temperature, humidity to speed up degradations. So this accelerated stability study testing method used to predict the long-term stability of drug, product, substance. So question number 7, that is accelerated stability testing is conducted for. So stability, the capacity of drug product to remain its identity, strength, quality and purity. Objective of stability study, determine the shelf life. Second, accelerated stability study, World Health Organization, Food and Drug Administration's stability study, ICH guidelines, European and Japanese. So ICH guidelines used for stability studies. ICH guidelines means I means international, C means conference and H means harmonization. International Conference on Harmonization. 3 countries are combined and to develop guidelines, that is ICH. That is which countries? That is European Union, second Japan and third United States. These 3 countries combined to develop that guidelines, that is ICH. European Union, second Japan and third United States. You have to remember this. For which purpose? To quality, safety and efficacy, as well as multidisciplinary approach to improve the quality worldwide, to improve the safety worldwide, to improve the efficacy of worldwide, and fourth, multidisciplinary. So there have different guidelines have given Q1, Q2, Q3, Q4, Q5, Q6, Q7, Q8, Q9, Q10, Q11, Q12, Q13, Q14. Q1A out of that, stability testing. So Q1A stability testing, Q2 analytical method validation, Q3A impurity testing, Q4 pharmacopoeia, in that Indian pharmacopoeia, British pharmacopoeia, as well as Q5 quality of biotechnological product, means like insulin, vaccines, etc. Q6 specification of new drug substance, Q7 good manufacturing practice, Q8 pharmaceutical development, Q9 quality risk management, Q10 pharmaceutical quality system, Q11 development and manufacture of drug substance, Q12 life cycle management, Q13 continuous manufacturing of drug substance, and Q4 analytical process development. So stability testing, the main objective, that is quality, safety and efficacy, to identify the drug capacity, strength, quality and purity. Stability, physical, chemical, therapeutic and microbiological substance, those are stable in different temperature conditions. That is called as stability testing. So today's lecture we learn about colloidal dispersion MCQs, rivology, multiple choice questions, core dispersion, micromeritics and drug stability. This multiple choice questions is definitely helpful for upcoming competitive examinations, GPAT examinations, railway pharmacist, or any other competitive examinations. When physical pharmaceutics subject MCQ will ask, so this type of MCQ will definitely ask. So try to solve question papers of regarding that examinations. So this video is definitely helpful for this competitive examinations. Thanks for watching this video, and this clap for you for watching this video once again. Today's preparation is the foundation of tomorrow's success. Remember, today's preparation is the foundation of tomorrow's success. Every steps you take, no matter how small, develop the path your dreams. Stay focused, stay work, and trust the process. Success is the reward for persistence and passion. Success is the reward for persistence and passion. Thank you for your attention.